I think the grade is very important in the success of this tool. So I know that it's a KCMS15 grade, and maybe you can tell us a little bit about what that grade is and how it benefits this tool.
Sure. So it is, we briefly mentioned it. This is a monolayer. It is a high aluminum content titanium aluminum nitride. What are some of the advantages of that? Well, one of the first advantages, it's a very tough coating. It really is. So again, we're trying to do everything we can to reduce the tendency of chipping. If you start to chip in stainless steel, those areas that you have a chip are going to make an extremely nasty, no pun here, but chip. So you create a chip or void on the tool, then as you start to machine the workpiece, you're going to get ugly chips. They're going to stick to that area, and your tool life is going to go down very quickly. So that's one of the big keys. Another big key, we talked about the polishing of that grade, so how much that helps. And then one of the final things is just to talk about what that high aluminum content does. So, we really have to think about the heat resistance.
We talk about thermal conductivity of the material. So we got to find a way to battle that. And the heat, like we said before, you and I have talked, the heat has to go somewhere. So we don't want it to go into the tool because that's going to be detrimental to the tool life. So this is where this grade comes in with helping with the high aluminum content. So
that's absolutely right. So one of the interesting things, so we talked briefly about like thermal conductivity earlier, and we talked about how much higher aluminum was. And of course, this is one of those, strange things in life, right? Aluminum by itself, very high thermal conductivity. But here we're not talking about pure aluminum. We're talking about aluminum essentially in a ceramic, in film. And so when we start to talk about more of this, incorporation of aluminum there, really we increase the heat resistance and the hardness of the coating with that higher aluminum content. And especially, that's good in very deep holes. So it works perfectly that we're talking about material, machining a material that tends to get quite hot. But we'd also like the ability to go 8 times deep or deeper. So that's a big advantage. There's all sorts of things that we can get into in terms of, if it's dry, near dry, aluminum oxide formation and things like that. But basically, just kind of in summary, that high aluminum content coating gives us very good heat resistance, actually reduces the thermal conductivity, makes it an extremely hard coating, and all those things are just, really, really important to keep those edges in good shape.
So that's like a force field around the
right? I mean, that's a good way to put it. And in this case, it's quite a nice looking one with that nice polish on it.
And then the through coolant that we have in these tools also help out with that issue with dissipating the heat as well.
Yes, definitely.